In this video here, we're going to look at equations involving fractions. Some of you will already have strategies for dealing with this. What I'm doing here is I'm giving you an alternative method of dealing with these that ties in with the work you'll have been doing with algebraic fractions. In particular, the idea of how we add or subtract them. With this first one here, I've got two fractions in my equation. I've got y over 3 equals y plus 2 all over 5. And this, using a standard method, can be quite difficult to solve. Some of you will have the idea of we can multiply through by a number to cancel out these denominators. And if that method works for you, brilliant, go for it. However, what I'm proposing is we change the fractions as though we were going to add them together. What we're going to do is we're going to rewrite this equation, but we are going to change it so that our denominators are the same for both fractions. So I need to change them to be both out of 15. I've picked 15 because 15 has a factor of 3 and 15 has a factor of 5. Now remember, in doing that, we have changed the bottoms, but we also need to change the tops at the same time. So what we are doing is we have to consider this first fraction. What have I had to do to the bottom to get 15? I've had to times it by 5. If I times the bottom of my fraction by 5, I have to times the top of it by 5. Now, I don't need to multiply both sides by 5 because I haven't changed this fraction. All I've done is I've essentially unsimplified it. So my equation is still balanced. If I look at the right-hand side equation, I'm going to have to times this 5 by 3. If I've times the bottom by 3, I need to times everything on the top by 3. So notice the brackets there. 3 lots of y plus 2. Now, remember, the equation symbol is telling you that everything on this side is the same to everything on this side. So what we are doing is we are comparing two fractions. If both of the denominators are the same, 15 and 15, that is telling me that my two numerators are the same. So essentially, I can rewrite this equation. I know the bottoms are the same, so the tops are the same. I have got a very standard equation there, something that we should all be comfortable with solving. So I'm going to multiply out those brackets, and I'm going to begin moving things about. I've got 3y on the right hand side that I want to get rid of. So to get rid of 3y, I can subtract 3y. By doing that, I'll be left with 2y's on the left, no y's on the right, and just 6. I don't want 2y, I want a single y. So I divide everything by 2 to get a single y is equal to 3. Remember, whenever you're solving an equation, you can do a quick check, go back to your original and see if it works. So y is equal to 3. So it means this side here would be 3 divided by 3. Well, that's 1. And then on this side, I'd have 3 plus 2 divided by 5. Well, 3 plus 2 is 5. Divided by 5 is also 1. So the two sides are equal, meaning this is definitely my solution. I can do the same with this. I have got 3 fractions here, over 2, over 4, and over 3. I'm going to rewrite these equations so that they have all got the same denominator. So I need a number that is in the 2, 4, and 3 times table. The smallest number in all of those times tables is 12. Now, some of you will be looking at this going, I would just multiply everything by 12, and that strategy will work. Remember, this is just an alternate way of doing it. So To change the first fraction, I'd have to multiply the top and bottom by 6. So I've sort of unsimplified this fraction to 6x over 12. The next one, I would need to times the bottom by 3, so the top would get multiplied by 3. 3 lots of 3x minus 2. The last one, to get a 12 on the bottom of that, I would multiply it by 4. So I'm doing 4 lots of all of that. So 4 lots of x plus 2. We could rewrite this as a single fraction because our denominators are the same. 6x minus 3 lots of 3x minus 2 all over 12. So common denominator of 12, this thing minus this thing, equals 4 lots of x plus 2 all over 12. Notice I haven't done any multiplying out here. I deliberately didn't multiply out in my first one, and I've deliberately not multiplied out in my second one. I'm going to wait till I get rid of the fraction to do my multiplying out. My denominators are the same, both the same on the bottom, so that means the tops have to be equal. So 6x minus 3 lots of 3x minus 2 equals 4x plus 2. I'm going to multiply out my brackets. Minus 9x plus 6. And the brackets on the right hand side. Once I've done that, I need to tidy up any like terms. So these two x terms on the left hand side of the equation, I'm going to group them together. 6x minus 9x will give me negative 3x plus 6 equals 4x plus 8. Now I can start solving it. So I've got x's on each side. I'm going to get rid of this minus 3x by adding 3x to each side. So adding 3x to the left hand side will give me 6, because the minus 3 and plus 3, they're what's called a zero pair. They'll add together to give me nothing. 4x plus 3x on the right, well, that gives me 7x plus 8. I want the 7x on its own, so I'm going to subtract 8 to give me negative 2 equals 7x. I don't want 7x, I want a single x. So if I divide each side by 7, I'm going to have x equals negative 2 divided by 7. So remember, nothing to worry about having a fraction as an answer. Looking at how complicated the equation is, you sort of half expect to get a fairly messy answer there. Now, these ones look a little bit different from the ones on the previous page, in that we've only got one fraction in them. However, what we need to remember is everything can be expressed as a fraction. We've got lots of what are called implied ones here. So the idea is all of this could be written as 2z minus 1 all over 1. The same can be said on the right-hand equation. We've got implied ones there. Now, we normally wouldn't write these, okay? And if we were giving answers, 11 over 1 is technically not the simplest form, so we wouldn't be doing that for our final answer. But as a way of helping us write everything as a fraction here, this over 1, actually writing in the implied 1, can be quite useful. So I'm going to begin with this left-hand one. I've got a denominator of 4, and I have written in this implied denominator of 1. I want the two denominators to match. Well, I can could change them both to 4, because 4 has a factor of 4 and 4 has a factor of 1. To do that, I'd be multiplying the bottom of the right-hand side by 4, so I'd have to multiply the top of the right-hand side by 4. This would give me z plus 5 over 4 equals 4 lots of 2z minus 1 over 4. My two denominators are equal, so my two numerators are equal. The bottoms are the same, so the tops have to be the same too. So z plus 5 has to equal 4 lots of 2z minus 1. Another standard equation here, so we multiply out our brackets to begin with, and then start solving. I want to take away a single z from each side. On the left-hand side, that will just leave me with a positive 5, because the z, negative z, they're a zero pair. 8z minus a single z will give me 7z, and it doesn't affect the minus 4. To get rid of that minus 4, I can add 4 to each side of my equation. That'll give me a 9 on the left-hand side and a 7z on the right, because minus 4, positive 4, another zero pair that will cancel out. I don't want 7z, I want a single z, so dividing each side by 7 will tell me that z is equal to 9 over 7. Final one. So again, I can put in these implied ones. I've got y over 6 minus 11 equals 2y. Well, I can write my 11 as 11 over 1, and my 2y as 2y over 1. Hopefully you've spotted what I'm going to make my denominators here. I'm going to make them all 6. So my 6 doesn't need to change in my first one, so my first fraction remains unchanged. I'm going to need to multiply the bottom here by 6, so I have to multiply the top there by 6. So instead of having 11 over 1, I have 66 over 6. Here, on the right-hand side, instead of having 2y over 1, I can times the top and bottom by 6 to get 12y over 6. So remember, each of these will simplify back to what I've got in the original equation. Right, on the left-hand side here, I've got two fractions with the same denominator, so I can write this all out of 6, and I'll have y minus 66 on the top, just doing y minus 66 there. That's going to be equal to 12y over 6 on the right-hand side. Because these two things are equal, and I've got the same thing on the bottom, I can say the things on the top are the same. So I can say y minus 66 equals 12y. And I can then go ahead and solve it as I normally would. So I want to get rid of this y here, because I just want y's on one side. So I'll subtract a single y from each side. That will leave me, if I get rid of the y, I'll be left with negative 66. On the right hand side, 12y take away a single y will leave me with 11 y's. I'll divide each side by 11, so I'll be left with a single y is negative 6, because 11 goes into 66 6 times.